Hey guys, today we're going to take a look at solving systems of equations algebraically, and specifically using a method called substitution today. So far with systems, we've been looking at how to take a system of equations, graph it, and then find the point of intersection to find the solution for that. And that method will work. And it is probably the easiest method and going to be your go-to method when it comes to taking your state test to be able to get a solution to that. But it's also necessary for me to teach you how to solve systems algebraically. That's part of the standard on this. And so we're going to look today at one of the two methods that we use to do that, called substitution. And so the reason that we need to know this is a couple of things. Number one, you will not always have access to Desmos to be able to solve systems. And so when you are in another class like Algebra 2 or when you're on your ACT, you're going to need to have another method for that. Secondly, when you get into Algebra 2, you'll be solving systems with more than two variables, and you're not able to do that graphing at all. And so understanding how this method works is going to be important to you for that. Additionally, on the state test, there will be some questions that will specifically ask you about some of these algebraic methods. And so we want to make sure we understand how they work so that you can get those kinds of questions right. So by the end of this lesson, you'll be able to solve system of equations algebraically by combining the equations using substitution. So this will be new for you. It's not something that you've seen before. It's also a little bit confusing at first, but if you just kind of stick with it and really pay attention, you should be able to catch on pretty quickly to what's going on in these kinds of problems. So let's get started. That's pretty much what I just said about how you're not always going to have access to Desmos. You'll need to be able to solve these for later classes, that kind of thing. So let's talk about the two algebraic methods that there are. There are two basic algebraic methods for solving systems. One of them is substitution, one of them is elimination. We're going to look at substitution today. We'll look at elimination tomorrow. So substitution is a form that we use when one equation is in slope-intercept form and one is in standard form. You can also use this if one equation is solved for either variable. So if you've got one that's already solved for x or y, you can use substitution. And technically, I didn't put this in here, but you could also use this if both equations are in slope-intercept form. But usually we see this method used when you have one equation that's y equals mx plus b and one equation that is ax plus by equals c. And then elimination is going to be the method that we use when both equations are in standard form. Now, like I said, we're going to wait and do that tomorrow. Oh, we don't have the right form because form's already on there. But that's when you've got a system that's created where you have x and y on the same side for both. If we have to solve one like that algebraically, elimination is going to be the way we want to go. So we use elimination for certain types. We use substitution for certain types. Today we're focusing on the substitution option. All right. So let's talk about how to do substitution. When we're doing substitution, the first thing we have to do is figure out what our substitute is going to be. So just like if you're playing a sport and you're going to make a substitution while you're out there playing ball, that means you're going to take a player out and put another player in their place. Now, let's say you're making a substitution in football and you have to substitute somebody who's playing the quarterback position. You're not going to put somebody in the quarterback position who plays defensive line, typically. You're not going to put somebody in the quarterback position who is your kicker because they don't have the same skill set. They don't have the same value. But we can replace the quarterback with another quarterback. Probably the second string is not going to be quite as good as the first string, but still you're going to have equal trade-off there because they're both playing the same position. So same thing applies in these math problems when we're doing substitution. We have to figure out a way to make a trade for something that has the same value. So the way that we do that is we look at the two equations and we determine which equation has been solved for the x or the y. Oh, I'm sorry, that's a lie. Don't put equation. Look at which variable has been isolated. I forgot how I worded that. So whichever equation has already been solved for x or y is going to be the one that already has an isolated variable. That's the variable that we're going to use as the substitute because we know what its value is. So then, once we do that, we're going to substitute the x or the y expression, the x equals or y equals expression, into the other equation in place of the x or the y. Now, if we do this correctly, we're only going to have one variable left in our equation. If you still have two different variables, like you still have an x and a y, then you've messed up. You need to do it again. Then you solve the equation that you have for the remaining variable. So if you still have an x, you solve for x. If you still have a y, you solve for y. Once you get that, remember that a system has an answer that is a point. It's an x and a y. So you have to find the other one. So once you know one of them, you substitute the number you get in for that variable in either equation. Typically, we put it back into the x equals or y equals equation, but technically you could do either and solve for the remaining variable. By the end, you'll have an x value and a y value, so you always give your answer as an ordered pair, x and y together. Okay. So let's take a look. There's kind of an elementary look at what I mean by this. And you don't have to really do anything with this slide, but I just want to kind of point out what I'm talking about. I think everybody would agree that 2 plus 3 is equal to 5. That's a true statement. And that 2 plus 5 is equal to 7. That's a true statement. And that 7 plus 2 is equal to 9. That's a true statement. So if I know these things are true, I know that 2 plus 3 equals 5, then I could take that, and anywhere I saw a 5, I should be able to replace it with a 2 plus 3, substitute it with a 2 plus 3, because they have the same value. So in that second equation where I have this 5, if I were to take that 5 out and replace it with 2 plus 3, I should still end up with a true statement. Is 2 plus 2 plus 3 equal to 7? Yes, it is. Still true. Same thing applies with this next one. If I want to take this 7, I know 7 equals 2 plus 5. Then in that bottom equation, if I wanted to, I could take the 7 out, replace it or substitute it with a 2 plus 5 and still end up with something that has the same value. 2 plus 5, and replace the 7, plus the 2 that was already there, still equals 9. That's still true. That's what substitution does, is it takes something out, replaces it with something else of equal value. It may not look exactly the same, but it has equal value because we know one is equal to the other based on the fact that there's an equal sign between them. And so that's kind of an elementary look at substitution. We're going to do that with algebra now. So let's take an example. We have y equals x minus 20 and x plus y equals 84. The first thing you have to do with a problem like this is figure out what you're going to use as your substitute. The thing we can use as a substitute is the equation that already has either x equals or y equals in the equation. So for this one, I have a y equals equation. This is going to be my substitute. So because I know that y equals x minus 20, in the other equation, anywhere there's a y, I could substitute an x minus 20 because y equals x minus 20. So down here where this y is, I'm going to swap that y out for x minus 20 because y equals x minus 20. So to make the first equation that I need to solve for the first variable, I'm going to take that equation that I'm subbing into, not the one that is the substitute, but the one that I'm going to replace something in. And I'm going to write it down, x plus y equals 84. But I'm going to take the y out and replace it with the thing that y equals, x minus 20. And that equation is going to be the equation I'm going to solve. So now we're back to circle, sign, draw the line where you're finding the value of x. Now, I substitute things in parentheses because I want to make sure that everything that gets substituted stays together. But when I look at trying to clear these parentheses, all I really have to do here is distribute this positive, which doesn't really change anything, right? It just becomes x plus x minus 20 equals 84. And then I'll combine like terms. So x and x can come together to make 2x minus 20. And then I'll continue working on that. I can add 20 to move it to the other side because that's the inverse of the subtraction. That gives me 104. Bring down 2x. And then we can finish this out by dividing by 2. Which tells me x is going to equal 52. So in my solution, the x part of my solution is going to be 52. So then to get the y value, I take that 52, replace the x in one of those two equations with 52, and solve for y. It will always be easiest to do that with the y equals equation. You can get a correct answer with either, but it's easiest to do it with the y equals. So if y equals x minus 20, I'm going to take that x out and put 52 in its place. So that 52 that I got right there goes down there in place of the x. And I'm just going to calculate that value. 52 minus 20 is 32. So my solution for this one is 52, 32. Now, some things to think about with this. Probably the most important part of all of this is just making sure that you can get this equation right here. Now, obviously, I want you to be able to solve it. But as far as the test questions on this will go, if there's a question that asks you to find a solution, you're going to throw that in Desmos and get a solution to it, period. But if there's a question that specifically asks you about the steps for substitution, the most likely thing they're going to ask you is going to be something about the equation that you get when you do your substitution. So being able to recognize what the correct equation there looks like is going to be important to you. All right, let's go. So here's another one. 2x minus 3y equals negative 1 and y equals x minus 1. Again, we want to start by identifying the thing that we can substitute. So the substitute will be the equation that is in either x equals or y equals to begin with. So for this one, it's this bottom equation, y equals x minus 1. If I know that y is equal to x minus 1, that means anywhere I see a y, I can put in an x minus 1 in the other equation. So in the other equation where the y is, I'm going to replace it or substitute the x minus 1. So I'm going to take that equation, keep everything else about it. So I'm going to keep the 2x, keep the minus 3. Where the y is, I'm going to take it out and put in x minus 1 equals negative 1. I've done my substitution. Please notice that everything else that's here is still here. 2x minus 3 equals negative 1. All is still there. I just took the y out, replaced it. I'm going to solve this equation. So when you have an equation like this that does have a number outside the parentheses, we have to distribute that number. So I'm going to distribute this negative 3 to start with. So that gives me, keep my 2x, negative 3x, positive 3, because a negative 3 times negative 1 is positive 3. And then to continue working on that, I can combine these like terms. So 2 plus negative 3 gives me negative 1x plus 3. And then on the other side, I still have negative 1. Keep going to solve it. We'll do inverses and subtract the 3. Gives me negative 1x, negative 4. Divide by negative 1. And x will equal 4. So that's just solving the equation once we get the correct equation written out. So x is 4. Then again, I have to come back and get the second variable. It is always easiest to use the y equals equation to do that. So if y equals x minus 1, and I now know that x has a value of 4, I don't know what happened, but it's not letting me erase. Okay. Well, I don't know what went down there, y'all. But anyway, I'll just rewrite it. So I'm going to do y equals 4 minus 1, which means y is 3. So my solution here is 4, 3. All right, continuing on. Now notice in this one that we have a y equals equation at the top and the bottom. So that means either one could be the sub. It's your choice which one you use. So I'm just going to use the top as the substitute and put it into the bottom equation. So I'm going to use this one as a substitute for the y in the bottom, which means everywhere there's a y in the bottom, I'm going to replace it with a 6x. So my equation is going to really read 6x equals 5x plus 7. Because originally it was y equals 5x plus 7. Well, if y and 6x are the same, 6x can equal 5x plus 7. Now we got to remember how to solve with variables on both sides. Hopefully you remember that when you have letters on both sides, you have to move all your letters to the left. So that 5x that's on the right, I'm going to subtract it to move it to the left. 6 minus 5 is 1x. 7 comes down. And 7 divided by 1 is still going to be 7. So I know my x is going to equal 7. And then we'll find our y. Again, you can use either equation, whichever one you want to. And in this situation, it doesn't really matter because they're both y equals. I'll just use the top one because one less step in the math there. But if y equals 6x, that means then y equals 6 times 7 because my x is 7. And so that means that y has to be 42. You also could have plugged into this equation instead if you wanted to, because 5 times 7 is 35, plus 7 would have given you 42. It's the same thing. All right, we'll do a couple more together and then let y'all try a couple and then go from there. Take a look at this one. So we have y equals -2, and then we have 4x minus 3y equals 18. So when I look at that and I try to figure out which equation can be my substitute, the top one is the one that is solved already, the one that's already in y equals. So y equals -2, which means everywhere that I see a y in the bottom equation, which is right here, I'm going to put a -2 in its spot. So in that bottom equation, I'll really have 4x minus 3, and I'll put -2 in for y equals 18. And again, we're just solving that equation. Circle a sign, draw the line. So I'll multiply first the -3 times the -2 and get a +6. So I have 4x plus 6 equals 18. Subtract our 6. So 4x will equal 12. And then we're going to divide both sides by 4. So x will equal 3. Now, when I go back to find my y, notice that they tell us that y equals -2. There's not an x to replace in that. So if y equals -2, then guess what y equals? -2. -2 goes in the spot for y. All right. I'm going to, what just happened? Oh, I tried to slide. Sorry, that's my fault. Okay, you're going to notice that I skipped a slide and went straight to this you try it. We're going to use this you try it as the last example and use the example that comes before it as the first you try it, because this has a slightly different kind of answer and I didn't go over one of these with you earlier in the slides. So the example that we skipped we'll come back to in just a minute. Looking at this one, if you're identifying the one that can be used as a substitute, hopefully you recognize that the bottom one has to be the substitute because it is the y equals, which means it gets to replace the y in the top. So when I write my new equation for this, I have 5x plus, where the y was, I'm now going to put 4 minus 5x equals 3. And again, we've got to solve this. So I've got this positive outside of my parentheses that I need to distribute, which doesn't really change anything, but still got to clear those parentheses out. So 5x plus 4 minus 5x Then I can combine like terms. I combine a 5x with a negative 5x, which gives me 0x. Now, if you remember when we ended up with 0x's before when we were solving equations, that meant we were going to have a special case scenario. And it really depends on how it turns out to know how that's going to play out. So we'll finish it and see what we get as a solution. So I'll subtract 4. I end up with an answer of 0 equals negative 1. 0 does not equal negative 1. So this has no solution. If there's no solution for the x, there's also no solution for the y, which means the whole thing has no solution. Now, if we had ended up with something like 0x equals 0, that would be infinite solutions. But because we have 0 equals a number, that's not true. False. That's no solution. Okay, there are 2 slides left, this example and then the very last you try it. I'd like you to pause the video, take a minute and work those 2 out, and then come back to the video to see if you were able to get those correct or not. So take a minute, pause the video, work them, and then come back and check your answers and see. Okay, take a look at what I got and compare it to what you got and see if you're able to get a correct answer. If you missed a part of that, pause the video again and look closely at the work. See if you can see where your mistake came in. I just combined my equations by putting this portion in for the y in this one. And then combine like terms, solve the rest of that to get out to my answer here. All right, and then the next one. This is what I was able to get for that one. Again, if you missed that or missed some part of that, pause the video and take a look at the work on it and see if you can figure out what you did wrong. I put this 4x minus 2 in place of the y up here. And then combine like terms again, swap sides. I put an extra 0 over here so I'd have something to move my plus 5 to. You might have possibly solved this the other way and moved your x's to the right and your numbers to the left. That's fine, as long as you still got 2.5. If you got 0.4, then you divide it backwards, and that would have kind of thrown your answer off there. All right, when you finish that, if you'll make sure that you submit them, and then you can move on to the practice on this. Y'all have a great day.